Good
And
morning, good afternoon, good evening, depending where you're joining us from. We are here again to reveal another CTF. This is number 28,
yep,
right? And yeah, so this is part of Wizer Secure Coding. We have those CTFs designed specifically for developers. And the idea is to break through this code, to hack the code. And I will let Itzik to basically explain what's going on here and reveal the solution, how to hack this code. This is the public version. So every 2 weeks, we introduce a new challenge and we retire a challenge. So this is a challenge we've retired. You still can, it's still live. You can still play with it and try it out after we show you the solution. But it's a really nice way to learn uh, everything about secure coding and tune into that attacker mindset. So Itzik, the floor is yours.
thank you, Gabby. So, yeah, challenge number 28. It says you're required to create some sort of one exclusive object pending approval, and one standard object to win the flag. And that's what we're trying to do. So, looking at the code, reviewing it quickly, we're going to see an endpoint. It's called create object, or create object, sorry, plural, because it goes within a loop and an array that is accepted from the user input, and it's going to create those objects. And there are two types of objects actually, exclusive and non-exclusive. The non-exclusive doesn't require anything. It's just being pushed automatically once you create it. The exclusive object, however, requires a passcode, which we don't have access to. Okay, so we are required to create an exclusive object, even two of them, one approved and one not approved. By the way, by default, it is approved. Um, so we need to create one that is approved and one that is not approved. So how do we do that? We exploit a vulnerability that we're seeing here that is a prototype pollution. So that's the
Okay,
CTF challenge.
yeah, so before you jump into the solution, we need to create an object, um, but we don't have the password, right? An exclusive
Yes,
object, and we don't have the password.
right,
And
right,
it will
exactly.
be let's call it an approver object. So potentially that can be a user that has approval rights.
Exactly. It's like, yeah, you got an invite, an exclusive invite to be an admin or something.
Got you.
Only admins can do that. So they have a passcode or they have some
Yeah.
sort of a key to do that. Yeah, that's the
Okay.
case.
Okay, so how do we, and it clearly says here invalid passcode. So it's, whoever built this tried to protect it, and there is an if statement, and it shouldn't be easy or it shouldn't be possible to create an object without this passcode.
Exactly, exactly.
Okay, so
So,
show us how an attacker they see this code. What do they do? How do you solve this
right,
CTF?
right. So the solution lays in prototype pollution. So when you look here, the key to everything is that we're assigning or merging the object that came from the input, the user input, with a local object, with something doesn't matter. But when we're doing that, we're automatically activating prototype pollution. Okay. So how do we exploit that? If we look at our Postman that we used it to solve this CTF challenge number 28, okay, we need to pollute the prototype with one object that says exclusive, and then send it already approved, okay, and one that is sent without approved, which the default is going to be false because the 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 objects that are not exclusive are created as not approved, and then a regular object which is not a problem. Okay, but how does it work, right? I mean, you see that if I run it, I get successfully created one exclusive object pending approval, and one standard object, which is exactly what I wanted. But how did this work, right? And the fact that it worked is that the first time I'm entering here, the object type won't be exclusive because the prototype exclusive is not there even, right? So it's going to go and push that object, but it's going to assign it. So it's going to activate the prototype pollution, create an exclusive prototype property with true on it, and automatically get false. So that is the not approved exclusive. That's the first one. Then how do we approve it? We push one that that has approved true and prototype polluted, and then it overrides the false, so we get one that is even approved. And the last one is easy. We just provide the name of the user, very simple. And that's how you solve it.
Cool. So for those that don't know what prototype pollution is, can you maybe briefly, I know that it's a little bit it could be advanced to some people, but just high level, what's the
Absolutely.
idea? Because it's something that very unique to JavaScript, right? Not only, but
Yes.
probably.
So not only JavaScript, but JavaScript is definitely one of the biggest pains on prototype pollution. So what is prototype pollution? The idea is here that we're taking an object from the input source and we're loading it into our system. By loading it, we're actually merging it with an existing local object. And what JavaScript allows us to do is to change the prototype of an object, meaning that you can define properties, you can define methods, you can do all sorts of things on the object, on the prototype, which is underscore underscore proto, right? When you do that, you can change the prototype. If you load it this way with a sign, those prototypes will actually become real values, will actually become real properties on the object that is now loaded. So while when you accepted it, the exclusive wasn't there, the underscore underscore proto of the product of the field exclusive said true. So then only when it's assigned after the if statement, sorry, when it's assigned here after the if statement, it loaded exclusive to be true. So now, yes, we have an exclusive object. So behind the scenes, at the end of the day, we have an exclusive object, even though we didn't even go through the path to create exclusive object. So prototype pollution is a really problematic thing that allows us to change the prototype of something, of certain objects, but it's only when we're loading an object from user input in, for example, with a sign or with internal merge.
Okay. How many do you think it's something that developers know about the prototype? Forget
Yes.
about the pollution. So just using the underscore underscore proto, all of that, is that
Oh,
something?
well, I think people know it mostly from security aspect of it.
Yeah,
I think not many developers actually use it. And again, I'm guessing here
yeah,
because I think it's a really advanced feature of JavaScript that people who actually want to trick and create prototypes and create real objects and do things like that are really working with. So again,
right.
I might be wrong, but I think standard JavaScript developer is not using on a daily basis the prototype, but they must be aware of it because even if they're not using it, it can be polluted by user input.
Gotcha. Okay, so let's talk about how to prevent this from happening.
Perfect. So in this CTF challenge, okay, we have the write-up that actually walks us through the code and explains what's wrong with it and so forth. And the most important thing is the takeaways. So first of all, prototype pollution is dangerous. As you can see here, it allowed me to change the logic of the system and to get access to something that I shouldn't have get access. However, the main thing is never trust the objects coming from directly from the user input and never take them and just load them. It's almost like insecure deserialization. You don't take the object and load it. You inspect it, or you create your own assign that assigns only the values that you want. You only merge the values that you want and you can trust. You're not just assigning a full object with everything it has. So that's the most important thing and probably the key stuff here that we need to remember.
Okay.
Consider using deep cloning. So if we're cloning an object, we can deep clone an object safely without having to clone their prototype. So there is Lodash, for example, a deep clone. So if the object is complicated and we don't want to create our own merge, we can use tools like that are safe. And then avoiding object.assign to merge using user input, because again, it does everything and more things than we even think. It actually activates the prototype as well, which is something we don't want to happen.
Gotcha. So it goes back to don't trust the user input, be very specific with coming in, reconstruct it from scratch if you need. Don't just take something that the user sent and start using it.
Exactly. That's key for almost every
Yeah.
vulnerability. We don't
Yeah.
trust data.
All those automations and all of those like frameworks that help us um, end up against us, basically.
Right.
Attackers use them against us. So
Right. So the one thing to remember is though, not user input is not only something that is provided by the user right now.
yeah,
It could be something that was provided day or two before and saved in the database. So we can't even trust data that is coming from the database, because imagine if we have a save method that could save this object somewhere in a record and
yeah,
then we load it. We can't trust it anymore. So we need to be very, very careful. Sometimes that there's an indirect risk that it ends up being the same risk,
yeah.
but it doesn't mean that everything coming from the user is the only thing that we should doubt and check.
Also, I guess within the logic and within the flow of the app, like if we're getting inputs, we need to check them regardless because we don't sometimes understand the whole flow of how we receive that object. So we need
Exactly.
to we need to assume, I guess, that it's it could be polluted.
Absolutely. We always need to assume that it could be polluted unless it's something that we've created, a variable that we've created.
Yeah,
Nothing outside can affect it.
yeah,
Coming from the database, coming from any data source, obviously user input that is
yeah,
direct or indirect, it's all we can trust. We
yeah,
need to make sure that we're copying in terms of objects. Now we're talking about prototype
yeah,
pollution. We're copying the properties that we need to copy. Just like insecure deserialization, we're not just gonna load it with a method that loads because it can do all
yeah,
sorts of other things that we didn't expect it to do.
yeah. Be picky. Take only the things you need and not everything.
Exactly. Yep.
Okay, cool. Itzik, thank you very much. This was great. And again, guys, if you wanna have tournaments like this, so this is just one CTF. You can see there are 6 here. They're all retired by now. But if you wanna challenge your team within the Wizer product, you can create those CTF tournaments for your own team. If you wanna join us once a quarter, we do like a public one, and we have tons of people that join, and you can compete against some of the best hackers. I think they're out there in security researchers. So this is really cool, and you can always practice using the retired one. So you can try to solve it on your own. If you can't figure it out, you go to the write up, you read it, and the payload isn't spit out over there. It's you're getting the instructions on how to basically build it, but you still have to use. You still need to learn and figure out how to do it. So it's really nice. So take advantage of this. Use it with your team. Learn on your own. There's so much to learn using those CTFs. So it's
Exactly.
very much, and we'll meet next week for another
Thank
one.
you.
Bye bye.
Hi, everyone.